So what are we going to try to do now is to do a small implementation together with coding for the problem that has a name. It's called triangle example. I don't know if you have been working with this problem before. Well, it's a very kind of book example of how you should. It's one example that's very often used in books to show how to do testing, and it's a small one, but still emphasize on some of the problems. So the problem goes like this. Consider a program which takes 3 integer values as inputs. Those 3 values are representing sides of the triangle. What you have to do with your program is to give an output message saying whether this triangle is scalene, isosceles, or equilateral. For those that are not familiar with these terms from math, scalene means that all 3 sides are equal, or no 2 sides are equal, which means that it's A, B, C. So everything is different. Isosceles, 2 equal sides, so you have A, B, B situation, and equilateral triangle is where everything is the same. So A is a triangle. So fairly simple program. Let's do it. But as I said, we will learn it in a test-driven development approach, which means that we will first write a test, and then we will implement the code to make the test pass, and so on and so forth, until we don't have the full implementation done. So let's see. Okay, let me remove this one. So I'm hoping you will be able to see. Very nice. So this is Eclipse development environment, and what I want to do here is to create a new Java project called Triangle. Most of these options are okay. What I want to do in addition is, so we have a folder for source files. I might want to add a new folder for test files. Okay. And what I also want to do is to add a library for JUnit so that we can use test automation. So this is a few clicks away. JUnit, we want to use version 4. Very good. And with that one, we have a project set up. So as I said, the first thing we need to do is to write a test. So let's create a new JUnit test case. It's JUnit 4, it's the version. The name will be test triangle. We can use this setup before and tear down after classes, and I will talk a little bit later what this means. We can also have some comments generated for the so we are a little bit easy to start with. And this is how, let me just remove this one I don't need, and this one, okay, we can leave this a bit down. Very good. So this is how one test class looks like, and it has all these classes set up for you. And basically there is only one test which is immediately set to fail. And we can see this if we right click on test triangle and we go to run as JUnit test. So if we execute this test, it fails. This is a red kind of a color. Yeah, and this is what we were expecting to happen. So what we want here is to change this and say we want to test a triangle class. So most likely we will have one class which is a triangle, which we will instantiate in a variable, and it will come for, let's say, with some default constructor. So there is nothing happening there. Of course, immediately you can see that Eclipse is warning us that this doesn't exist. But we will and this is essentially our first test case. So we wanted to create, okay, it's not a real test case because we are not comparing if we managed to actually create this class, but the point is that the test case is failing already because you cannot compile it even. Not just that you don't run it, but you cannot even compile it. This is also considered a failing test case. So let's first make that fix that one. So we will create a new class, which is a triangle class. No, yeah, that's okay. Very good. And I think now, okay, yeah. And now we can at least compile our test, which is a good sign. But now we need to complete it. So the first thing about testing, as I said, is about comparing expected behavior with the actual one. So for that, we have JUnit has a built-in functions called assertions. Assert equal, in our case, is needed, equals, and we want to compare that when we call our triangle function, the type of the triangle is equiliteral, so that all sides are equal. Right? And the actual output we will get from triangle, for example, get type, and then we say 3, 3, 3. So what this test case is, when we call the triangle for a specific type, the output of that function will be, we are expecting it to be equilateral. So this is our test. And you can already see that it's failing because we don't have this implemented yet. But let's quickly implement it here. Okay, we need a constructor here. We will not do anything there. And then we need a method which will return string called getType, and it will accept 3 integer inputs, A, B, and C. Right? Okay, let's do it like this for now. Great. So our test can now compile, which is nice, and that probably means that we can also execute it. So run as JUnit. So now we run the test, and the test is failing. Why? Because here it says it's expecting equiliteral, but result was empty. We need to fix now in the test-driven development manner. We need to fix our code to make this test pass. How do we do that? We need to fix code to make this test pass. No mumbo jumbo, nothing. We need to fix code to make the test pass. That's what the test. But now the problem is you need more tests. So let's move further. So we can copy, before that one, so this was a test one. We can also use, so let's see like this. If we create a new test, where we expecting right. So we have a new test. We can run this, and we can see that the first test is still passing, but the second one is failing, because when we invoke it, we are expecting isoscales for these values, but we are getting still equilateral, and you can see it here. Sorry for that. Yes, so here. So it's expected as this, and this is what we got. Before we fix the code to pass this test, I just wanted to show you this. We have these specific classes here where we can set up some pieces of code which will be executed once before all the other tests are executed. In this case, what we want to do is this constructor triangle, we want to take it away from the code. So let's create here a global variable called triangle. And then in the setup of the tests, we want to say initialize this triangle as a new triangle. Right. And then we don't need these things here. So again, let's double check. This is something that you will do in the very beginning, not the way I've done it, but I just wanted to show you what's the meaning of this. So every time, so now we prepare this class and then this variable, and then it's used by every single test, no matter how many we have. But now let's fix the code. So what we have here, okay, if A less than B. Okay, works. Fix the code to make the test pass. Great, we need more tests then. The third one is scaling, and this is where we have all three different. First we have to run it. Yes, actually this is also important to say. So you have to create a failing test and you have to run it, even though you know it will fail. This has to do something with psychology, I guess, because you have to see that it's red. There is something to be fixed. Like that's how engineers think. There is a problem, and now I'm going to fix it. So yes, you have to run it to see that it's failing, and now you're going to fix it. So let's see, how are we going to fix this? So if A is less than B, and B is less than C, very good. Works. Great. I implemented. I have all the things that are specified. I'm testing it for all types of the triangles, and it's working.